If you went to high school, unless of course you're still in high school, then you likely remember Algebra 1, or are currently in it. Algebra 1 is basically the next stage of math after just working with normal numbers, and you start to apply variables such as x and y. This is about the time where math takes a more abstract direction, leaving many Algebra 1 teachers asked by students, why am I learning this if it doesn't really apply to real life? But is Algebra 1 really that abstract, and how hard is Algebra 1 really? For Algebra 1, mostly everything is just learning how to combine numbers, essentially just simplifying numbers. 2 plus 2 is really just another way of writing 4. Like, would you rather have $9 or 3 squared dollars? Really doesn't make a difference. It's just another way of writing the same thing, and you're not actually solving for anything. And that's why there's not really an equal sign. It's really just an expression, right? An expression is where you have just a statement of math. There's no this plus this equals, right? The equal sign. This. When you have the equal sign, that's really where it means there's something to be solved. And that something to be solved for is what we call x, right? Algebra is all about finding the missing piece of information. That's why we say like it's x or element x, right? X is just to describe what we don't know, and you also end up with like an x on either side of the equation, right? So if you have a 2x over here plus 9 equals x, you're going to have to get that x to one side. You're going to end up with a statement that effectively says this x equals this, right? It's just, you can read it in English. If you just say what the sign is instead of looking at it, it just says x equals, right, 9 or whatever it ends up being. So yeah, Algebra 1 is essentially where instead of simplifying, you begin to learn to deduce something, right? You're now figuring things out. So ultimately, it's not that hard, but you do learn a lot of different techniques for solving for it. Out of 10, I'd probably say it's a 4 in difficulty, but that's only because we're working with the trivial case. The trivial case is a single x. In Algebra 1, you graph in 2 dimensions. That's where you really learn to graph. To make a graph, which is actually called a line, that's that line. And if it's curvy, it's called a curve, but we're just going to work with the line. It is a series of points that's plotted on a rectangular coordinate system. And honestly, a Algebra 1 student could probably even, given that if they're driven enough, could probably even do it in 3 dimensions, which is really cool. So that's not just going to be x and y coordinates, it's going to be x, y, and z. The line is actually an equation. The equation is famously y equals mx plus b. So y equals m being some constant, which means it's not a variable, even though it looks like a letter. It is the general form of the equation. If it's less than 1, so it's like from 0 to 1 rather, it's going to slowly get more horizontal. If it's greater than 1, it's going to get steeper. It can also be a positive or a negative number. If it's negative, it's going to go this direction. It's not going to cross through this first quadrant, or it's not going to cross through the third quadrant. And if it's positive, it's kind of the vice versa, right? It's not going to cross through either the second quadrant or the fourth quadrant. The b in the equation, y equals mx plus b, the b is going to vertically adjust this, right? So like, let's say we have the equation y equals x plus 4. Now we're going to choose a 0 for x, right? And it's going to be y equals x plus 4. X being 0, we get y equals 4. Now, even though we have a 0 for x, it's going to move that line vertically up. And if it's a negative number, let's say it's negative 4 for b, it's going to, if we choose 0 for x, it's going to move it down. There's a million applications for plotting this line. You can plot it for sales, or I don't know how much money you're gaining every single month in your bank account, or all kinds of money related things, really, which is why it's actually really useful. And even though it seems like an abstract thing because it's a line on a graph, represents a lot of things in reality that aren't too abstract. It's not too difficult, and I'd probably give it a 5.5 out of 10 in terms of difficulty. Also, there's another little interesting aside. No teacher would probably ever say this because they don't want to like take away from the main point for the average student in the class. But because you're watching this video and you're probably a little bit above average. We'll say this. These lines already kind of exist on this graph. Every single line is just a bunch of points, right? And they're all connected and they're all infinitely close. There's literally like an infinite amount of lines, infinite amount of points on this line. What this means is that there's a set of points, right? And those form a line. Therefore, since there's an infinite amount of points on the graph, it really means that there's already an infinite amount of lines on the graph. So you're kind of doing the inverse of solving an equation y equals mx plus b by choosing. Normally you try to find with an equation, you try to find what x equals, find what y equals, but instead you're kind of revealing by working backwards from having the result x equals 5 or whatever you choose to plug it in. You're choosing the result and it's pumping out what the y equals. So you're actually revealing a line that is already there. You're kind of unearthing this line, and something that's on one line will never appear on another line. So you've dug up a line that already exists there, which kind of gets into the idea of like, are these lines already there or did you create them? Well, I'd say they're probably already there. So moving on to our next section, x's and y's, where do they cross? So you'll have one equation right here, a line, and one equation right here. They're going to cross eventually because they're not parallel. If you have sales here and the amount of money you're losing here, well, where's that point where they cross and sales outpace the amount of money you're spending or losing, so to speak, right? This is actually, in my opinion, the most enjoyable part of Algebra 1. So yeah, it's a really easy, however, if it was just fun, somewhat satisfying challenge to Algebra 1, I'd give it like a 3 out of 10 in difficulty, something like that. It's really not too hard for most people, but there's a very interesting form of application problem that comes up in algebra, and it's typically called a mixture problem. So here's a typical mixture problem that you'll see in Algebra 1. If you have $1 made up of dimes and quarters, and there are 8 coins in total, how many dimes or quarters do you have? Okay, first we gotta define our variables. Dime, x, y, it's gonna be 25 cents. Then we're going to have to set up our equation. X plus y equals 7. Okay, then 7 coins. Okay, then a dime is 10 cents, right? 25 cents. Hit that with the y. Oh no, we forgot the y. Okay, but that equals $1. That's going to be a time loss right there. Okay, try to do the graph skip. Let's see if we can get it frame perfect. And okay, sick, we got it. Y equals y minus x. Okay, there's a time loss right there. You wrote that wrong. Y equals 7 minus x, right? It gives us this line right here. Then we're going to plug in our decimal equation. 3.25y equals 1 minus the dime, right? And you get 5 dimes, 2 quarters. It's gonna be... Overall, I would say just because of those mixture problems, I'm going to give this section of what's really called systems of equations, where there's one type of like one line over here, one line over here, seeing where they cross. In the beginning, 3 out of 10. Now, 8 out of 10. Tough. Algebra 1 finished with an average of a 5.833. I remember when I was in Algebra 1, I was very desperate to get to a higher math class, and I didn't even enjoy it for what it was. I was so desperate to get to calculus. I didn't even want to talk about that I was in Algebra 1 in college, actually. And it stopped me from enjoying what was really some interesting takes that you could take away from Algebra 1. That thing that I said about finding where the lines cross and how it applies to the real world, just being able to look into what a line is for the first time using Algebra 1, it actually gave you a very solid foundation for things like linear combinations. These lines, they're the exact same lines that you use forever. Algebra 1 can be a really deep and rewarding experience if you slow down and appreciate what you're actually going through. I really encourage people to play around with the math in Algebra 1 because it's still easy enough that you can do a lot of different things. These are classes that are very enjoyable and rewarding to be able to like really feel what's going on with the math.